You have to discuss doubts with them.
So we have, so but we didn't get really enough classes for that. So since we have a class today, so doubts discussions, so could you spend a little bit time at least, because
No, there is no cross involvement. That is not something which is done under the given circumstances. It creates certain problems. Like you will not be able to, of course, understand because you are thinking it only from a student's perspective. But then there are certain other things or other problems that happen. So while the syllabus is going on, teachers don't interfere in each other's tracks. That's like kind of an unsaid understanding.
So like physics, the teacher other track answers the questions if the doubt class is there sometimes.
But inorganic, organic and physical
Both almost
is different
subjects.
It's totally different.
Makes sense.
And it just creates a bit of more confusion. Okay. So we'll not get into that at all.
Okay, sir.
Now, continuing, क्योंकि हमारा भी थर्मो का डिस्कशन इम्पोर्टेंट है, अभी बचा हुआ है. We need one more lecture to complete thermo from our part.
After today.
हाँ, so last class में हम लोगों ने second law का discussion close करा था.
हाँ, Gibbs के साथ.
Right, with Gibbs free energy, applying that on chemical reactions. And then I gave you some background for the third law. That let's say for a reaction, we are trying to determine delta H. That is what we did in the first law. So by definition, delta is final minus initial, so products minus reactant, but we were not able to define the absolute value of enthalpy. So we defined a reference called as enthalpy of formation for elements and compounds. And based upon that, we come up with the enthalpy change for a reaction. Similarly, second law में हम लोगों ने पढ़ा था that delta G of a reaction is of importance to us. And again, delta G, by the core definition of it, final minus initial, can be calculated as Gibbs free energy of products minus Gibbs free energy of reactants. But the same problem persists, that we can't determine the absolute value of Gibbs free energy. So we defined this reference, delta G naught formation. And then for elements and compounds, we gave what is the description of it and used it to define the delta G naught of any reaction. Correct? Then lastly, we were talking about this term of delta S naught of a reaction. And here we said that third law comes of help, where third law allows us to define absolute values of entropy of substance. And we need not define any entropy of formation. जैसे हम लोग ऊपर define कर रहे थे ना, enthalpy of formation, Gibbs free energy of formation, वो हमें define करने की जरूरत नहीं है. We can put the absolute values to use and get the delta S of the reaction. So what is it that third law is saying? Notice करना. इसका statement ध्यान से observe करना. एक word important है. Entropy of perfect crystal of pure element and compound is zero at absolute zero temperature. Now, एक वर्ड को वापस से reiterate करेंगे. हम लोग entropy के बारे में बात कर रहे हैं. Now, we have talked about different interpretations of entropy. And do you remember a statistical thermodynamics based interpretation of entropy? It represents the possible microscopic states in which the system can exist for a given set of macroscopic parameters.
That's so.
Okay, so keeping that interpretation in mind, what we are looking at is a perfect crystal of a pure substance. Now, what do I mean by perfect crystal? That means there is a well-defined order of atoms or molecules. ठीक है? Crystalline solid के बारे में आपने पढ़ा है ना? Crystalline solids have well-defined order of atoms or molecules. And what do we mean by perfect over here? That there is no defect. That means exactly where an atom is supposed to be there, it is there. Okay, there is no distortion, there is no atom missing, there is no atom displaced. Ekdam perfect crystal, no defect. And it is pure. Pure in the sense, जिस element का है, right? तो उसी के atoms है. There aren't any other atoms. ठीक है, there is no impurity. Now, ऐसे crystal का absolute zero पर, ठीक है, 0 Kelvin जो theoretical concept है, ठीक है, 0 Kelvin is not a practical achievable concept, but जो theoretical concept है 0 Kelvin, at that temperature, the entropy associated with that crystal is 0. Why? Because
but how?
there is no randomness associated. There is just one arrangement. There is one microstate in which the atoms or molecules are present. In this condition, like you have, as I said, identical atoms and they are present in one particular manner. Okay, without any flaw, without any defect. Okay, and they are at 0 Kelvin. When I say 0 Kelvin, that means there is no kinetic energy. Everything is at rest. There is no motion, there is no vibration. The atoms cannot even wiggle from one position to other position. This is where they are supposed to be, and that is where they are. So there is only one possible microstate, and corresponding to that one microstate, right? There is no randomness, there is no disorder, there is no entropy. The entropy is 0.
So, a question.
Now,
so we can't take a look at it from the physics standpoint of view here. So we can't take a look at it from the physics standpoint of view, and so I'm confused about which interpretation.
as I told, the interpretation that we talked about in statistical thermodynamics, where entropy represented the possible microstates in which the system could be present for a given set of macroscopic parameters, or the degree of randomness, measure of disorder. That is what entropy was. So yahan par, as you can see, that in case of this condition, perfect crystal, absolute zero, pure substance, there is no disorder. There is only one microstate associated with it, and uska absolute value of entropy can be assigned as 0.
ये hypothetical है ना?
नहीं, hypothetical नहीं है. This is, you can say, theoretical. हाँ, मतलब ठीक है, hypothetical
0 Kelvin वाला ना.
हाँ, मतलब hypothetical is when you say hypothesis है, ठीक है, तो ठीक है, interconvertibly use करते रहते हैं हम लोग hypothetical या theoretical word को. But yes, this is theoretical. Like जैसे हम लोग internal energy के बारे में बात करते हैं, ठीक है, तो internal energy के बारे में मैंने आपको क्या बताया? That it is the sum of kinetic energies and potential energies. Now, 0 Kelvin पर kinetic energy 0 हो जाएगी, ठीक है, at 0 Kelvin kinetic energy is 0. But what about potential energy? ये तो non-zero values रहेंगी, ठीक है. This is something which we can't determine, and as a consequence, the internal energy or enthalpy or Gibbs free energy का absolute value we cannot determine. But entropy के बारे में, this is where the third law of thermodynamics is coming in, that entropy के बारे में we actually can come up with the absolute value given each and every word of this statement is applied. 0 Kelvin per perfect crystal of a pure substance, the entropy can be assigned as 0. Now, based on this definition.
So can you explain what a perfect crystal is again, just in short?
Perfect crystal is that there is a regular pattern of arrangement of atoms. There is one particular arrangement that is supposed to be there, right? And all the atoms are present in that arrangement only. There is no defect, there is no like randomness that is coming in. ये ऐसा नहीं है कि ये एटम यहाँ से विगल होके यहाँ पे आ गया या ये एटम की जगह कोई और इम्प्योरिटी आ गई. नो, बिकॉज देन दैट विल represent more possible microstates.
Yes.
So we are talking about a perfect crystal. ठीक है, अगर मान लो क्रिस्टल का में कुछ imperfection आ गया तो फिर एंट्रोपी जीरो नहीं रहेगी. इट विल बी समथिंग नॉन जीरो, राइट? अगर कोई इम्प्योरिटी आ गई तो भी फिर हमारे क्रिस्टल की एंट्रोपी जीरो नहीं रहेगी बिकॉज देयर विल बी मोर पॉसिबल माइक्रोस्टेट्स, राइट? एब्सोल्यूट जीरो टेम्परेचर नहीं है, हायर टेम्परेचर है, तो देयर विल बी सम थर्मल एनर्जी एसोसिएटेड जिसकी वजह से मॉलिक्यूल्स कैन वाइब्रेट, कैन डिस्प्लेस फ्रॉम देयर पर्टिकुलर लोकेशन, right? So there are more possible microstates. Again, entropy zero नहीं रहेगी. Only when all these three are satisfied, we say that the entropy associated is zero.
सर आप कोई एग्जांपल दे सकते हैं इसका?
यही एग्जाम्पल है इसका. Like this is the exact statement. मतलब इसका प्रैक्टिकल एग्जाम्पल नहीं है तुम्हारे लिए because zero Kelvin is not achievable.
हाँ, ओके, यस सर.
So this is describing you. अब इसका यूज कैसे होगा, ठीक है, टू कैलकुलेट द एब्सोल्यूट वैल्यूज ऑफ एंट्रोपी, ठीक है, तो वो आप नोटिस करना यहाँ पर थ्रू दिस क्वेश्चन.
सर वो फॉर्मूला खाली एक बार लिख लेना.
हाँ, पहले इसको लिख लो एक बार, फिर ये वाला क्वेश्चन ट्राई करो.
So, but according to statistical thermodynamics, entropy is the number of microscopic states.
नहीं 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 नहीं, वापस से पढ़ो. एंट्रोपी इज अ मेजर.
ओह,
ठीक है, तो एक्चुअल जो वो था ना, दैट इज दिस kb ln n. ये मैंने पता नहीं उस टाइम पे लिखा था कि नहीं लिखा था आप लोगों के लिए, बट दिस इज अ वेरी फेमस इक्वेशन. तो ये जो n है दैट इज व्हाट रिप्रेजेंट्स माइक्रोस्टेट्स. तो ln of 1 जीरो होता है ना.
yes.
This question
तो
20
इसमें
is
हम
from
लोग
a
को
module or from where?
सॉरी,
Is the question 20 from a module?
या
So so we start solving.
हाँ हाँ.
So which exercise is this from?
सॉरी,
Which exercise is this from?
ये वो है एडवांस लेवल.
Okay.
To
Very
get
good,
equipped.
sir.
नहीं नहीं,
No, there's one advanced level exercise. It's just
Ah,
called
yeah,
advanced level.
वो है हाइपोथेटिकल कॉन्सेप्ट. जीरो केल्विन इज अ हाइपोथेटिकल कॉन्सेप्ट. तो एब्सोल्यूट काइनेटिक एनर्जी टू बी जीरो इज आल्सो हाइपोथेटिकल, बट देयर इज नथिंग रॉन्ग इन सेइंग दैट एब्सोल्यूट जीरो केल्विन पर काइनेटिक एनर्जी इज जीरो, राइट? वैसे ही वी आर सेइंग दैट एब्सोल्यूट जीरो केल्विन पर एंट्रोपी एसोसिएटेड is zero for not everything, for perfect crystal of a pure substance.
सर तो हम लोग क्या ऐसा अज्यूम कर ले कि हर चीज प्योर सब्सटेंस है?
नहीं, तो मैं अभी उसी के बारे में आपको बताऊंगा आगे. पहले इस क्वेश्चन को वर्क करो, फिर आई विल टेल यू.
How does the heat capacity change? So
Heat capacity क्यों? मतलब water का, steam का.
let's say the heat capacity was solved from 0 Kelvin to normal melting point. Cp equals to 0.05 T. So then how does it like change in others, like other than, for example, 200 bar? Oh yeah. Wait, got it.
Sir got disconnected, right?
Yeah.
No, he's still there.
He's still there.
What was the value of CP given?
CP of
Read it from the screen now.
The
It's
question
there.
is on page 237.
Arey, sir has got disconnected once.
No, you can still see the screen.
No, I cannot see.
Oh, we
He's
cannot
just
see.
messing.
I can't. It's not
I-
visible for me.
Then check your own things. I can still see the screen.
Punch, that's
Your
it.
screen has hand.
Yes, so okay.
I think I got disconnected.
Yeah.
Wi-Fi. Anyways, थोड़ी देर में आ जाएगा. अभी I am on hotspot only. Let's see how long it lasts. Anyways, दिख रहा है screen सबको अभी?
Yes, sir.
So
So I paused the recording then. Could you please turn it on?
Pause हो गया क्या?
हाँ मैंने किया था सर.
Okay.
So can you go to the question?
So do we consider all processes to be reversible?
हाँ. You derive using reversible only, like you have been doing, and then that will be applicable for irreversible also because entropy is a state function.
So could you go back?
Yeah,
to the
yeah.
question?
Correct.
Right? तो यहाँ पे आप लोगों को इतना समझ में आ रहा है that you need to break it down into these steps.
So
Sir,
where is
आप
question?
क्वेश्चन पे जा सकते हो प्लीज.
Question
Yeah.
slide पे.
Oh, मैं question slide पे नहीं था क्या?
नहीं सर.
So how do you find a what do you call? You have so many notebooks. So like what do you call sections? How do you find the right one when you want?
By the date and
मैंने
batch.
लिखा था उधर Zenith 456.
I know, but like other stuff also. If you want to find it, how do you find it?
Classification of book.
It is just well organized.
समझ में आया कैसे जाना था?
Yes,
So
sir.
wait,
मतलब ठीक है, एब्सोल्यूट वैल्यू कैलकुलेट करने में टाइम लग जाएगा. लाइक यू विल हैव टू, ऑल्दो द डेटा इज नॉट बैड, इट इज समथिंग व्हिच इज अ वेरी गुड डेटा एंड यू कैन मैन्युअली डू ऑल द कैलकुलेशंस, राइट? बट द इंपॉर्टेंट थिंग इज दैट यू आर एबल टू ब्रेक इट डाउन and break it down into steps that we have already studied. तो जैसे हीटिंग ऑफ सॉलिड है 0 से 200 केल्विन, इसका एंट्रोपी चेंज अपने को आता है?
NCP, so we can use NCP ln T2 by T1. No?
नहीं, you will not use that. Why? Because that formula was based on the assumption that
Yeah.
Cp was independent of temperature.
Yeah.
You will have to go even more basic. Like you will have to use integral dq by tc. And then यहाँ पर put 0.053 t upon t, तो t कैंसिल हो जाएगा. ठीक है. फेज चेंज में you can go from the scratch or you can use the formula also over here because both are going to give the same answer. So you get delta H fusion upon the melting point temperature, right? Then you go about वापस से doing heating of liquid and use the base formula. Why? Because the Cp is again dependent on temperature, right? Then you talk about the phase change, vaporization, वहाँ का delta S, and then आखिरी में heating of the gas. यहाँ पर you can apply the formula because Cp is constant over here. So you will be simply able to get NCP ln T2 by T1. Once you do that, then adding all that up will give you the result on the right hand side. However, I want you to focus on the left hand side, that the left hand side will come out to be entropy at 600 Kelvin minus entropy at 0 Kelvin. Now, अगर क्वेश्चन में कुछ नहीं मेंशन किया हुआ है तो हम ये अज्यूम करेंगे कि दैट 0 केल्विन पर एंट्रोपी 0 था, राइट? इट वाज अ परफेक्ट क्रिस्टल एंड नो डिफेक्ट एंड प्योर. Or sometimes in question there is this term called as residual entropy that is given. So in case, let's say there is some imperfection, there is some impurity, then there is no well-defined order, there is more than one microstate and corresponding to that there is some residual entropy. Okay, you need not worry about the calculation of residual entropy. This would be a direct value given to you. So you just plug it as the lower limit over here and get the 600 Kelvin ka entropy.
so what you've done is just calculated the entropy change throughout the process and then just find out the S total companion to the 0, 1, right?
Correct. So the total change, because entropy is an extensive property, so it is additive in nature. So different steps का delta S निकाल के मैं add भी कर लूँगा तो कोई दिक्कत नहीं है. That will be my delta S total only, right? Now the right hand side is something which I have calculated from each step, added and put over right hand side. Left hand side जो delta S total है, ये मेरा क्या बन जाएगा? अगर मैं सारे left hand sides को add कर देता हूँ तो it will eventually be 600 Kelvin minus 0 Kelvin का entropy. And that is where I then talked about 0 Kelvin के entropy के बारे में कैसे सोचना है.
So here we took n equals to 1 because Cp values are given in per mole, right?
Correct. तो ये एक calculate the molar entropy ही चल रहा है.
अच्छा.
ठीक है, like the question should mention molar entropy यही, because एक मोल ही हमने लिया हुआ है सब्सटेंस. ठीक है, समझ में आया?
Yes, sir. Could you give 2 minutes to note this down?
हाँ बिल्कुल नोट डाउन करो.
सर मेरे को रेसिडुअल एंट्रोपी का पार्ट अब तक समझ में नहीं आया सर.
तो मैं दोबारा समझा देता हूँ. एक बार इतना कॉपी कर लो, देन आई विल स्क्रॉल डाउन, आई विल मेक यू राइट एंड आल्सो री-एक्सप्लेन इट.
So could you scroll a little bit up? Just I take a screenshot of the question also.
पहले इतना लिख लो फिर मैं question का
In the
screenshot
module, page 237.
Have it
question.
in the module.
So isn't it melting, not fusion, in 200 Kelvin? So
Sorry,
isn't it not fusion, it's melting?
एक ही बात होगी ना, fusion is melting only.
Fusion is okay.
It's both ways.
लिखा?
I'm nearly done. So.
Now, अभी जैसे मैंने बताया, मैं रीहाइड्रेट कर देता हूँ दैट लेफ्ट हैंड साइड पर जो डेल्टा एस टोटल रहेगा वो एंट्रोपी एट 600 केल्विन माइनस एंट्रोपी एट 0 केल्विन आ जाएगा.
Yes. हाँ sir.
अब जो 0 केल्विन पर एंट्रोपी है उसके बारे में दो चीजें होती हैं क्वेश्चंस में. या तो कोई इंफॉर्मेशन नहीं मिलेगी, अगर कोई इंफॉर्मेशन नहीं मिल रही है तो आप उसको 0 असाइन कर दो. ठीक है, अज्यूम दैट 0 केल्विन पर इट वाज अ परफेक्ट क्रिस्टल ऑफ द प्योर सब्सटेंस. और इन केस कुछ वैल्यू मिलती है तो उस वैल्यू को रेसिडुअल एंट्रोपी बोला जाता है. ठीक है, सो इट इज इन केस देयर इज नॉट अ वेल डिफाइंड ऑर्डर. ठीक है, कुछ डिफेक्ट आ गया, कोई इम्प्योरिटी आ गई, तो इसकी वजह से क्या होगा, देयर विल बी मोर देन वन microstates, there will be randomness, there will be disorder, right? So there will be some finite entropy associated, and that is what is being called as residual entropy. Now uska value directly question mein mil jayega, you don't need to bother about its calculation in case it comes in question.
So we took delta S total as delta entropy at 600 minus entropy at 0 because entropy is additive, right?
Entropy is what?
Additive in nature.
हाँ, लिखा सबने?
Yes, sir.
So now that I am able to define the absolute value of entropy, I should be able to use that and calculate the entropy change of a reaction. Right? तो आप लोगों को अभी कुछ ऐसा entropy of formation define करने की जरूरत नहीं है. When you will notice questions like the one below, you will get standard values, absolute values of entropy. Just plug and play into the formula, right? Product minus reactants, and of course multiply by coefficients because they will take care of the moles, and get the answer.
What was the answer for the previous question?
205.8.
Okay.
So joule per mole, you read.
Joule per mole Kelvin.
So for the enthalpy of utilization, all those long, what do you call all those? We can do that for this also, right? Like it's the same thing, thermochemistry.
Yeah. In fact, I'll make you do one question. इसका आंसर निकाल लो, फिर you will see that question which I'm going to ask you.
So what is SI? So
What's your question?
what's SI?
SI.
Means like, you know, in physics we have summation mi xi upon summation mi from 1
What?
I is equal to 1
Like
to
S
n.
S is entropy and I is the value, like 1, 2.
It refers to each product.
I know, but it says to be okay. Wait.
Just to represent.
Is it okay? Fine, but what exactly is it?
We write summation like Ri from I going from 1 to 10, like that. It's that I.
I once say I
I
till
know that, so I'm not
one
trying to
to
understand. So you said that we
product.
can't define standard entropy of formation of compounds. So what is SI here?
Absolute value, ना?
Absolute.
ऊपर नोट के बारे में पूछ रहा होगा.
Not is the standard conditions.
No, that's not what I'm asking.
SI is the absolute value, not some relative value or reference value that we define. Like in case of enthalpy or Gibbs free energy.
Done, sir.
Yes, sir, done.
Correct. A option आ जा रहा है?
Yes, sir. A.
हाँ सही है. डायरेक्ट फॉर्मूला सब्स्टिट्यूट करना
Direct
है.
formula ही डालना है भाई.
Yes, sir.
Very good. तो फिर अब इस क्वेश्चन का आंसर कर दो.
सर ये CO के नीचे CO2 के नीचे वो सब हीट कैपेसिटीज है.
हाँ, नहीं हीट कैपेसिटी नहीं है, मतलब क्या चीज हीट कैपेसिटी पूछ रहे थे?
-26.42 -94.05.
डेल्टा एच नॉट फॉर्मेशन है, ये डेल्टा जी नॉट फॉर्मेशन है, और ये
हाँ.
एब्सोल्यूट वैल्यूज है.
ओके.
You said about balancing, but it's already balanced.
एग्जैक्टली. हाँ.
How balanced है actually?
Yes,
Just
sir.
put it as a caution saying that
Oh, sure, check it. Yes.
Isn't the reaction already balanced?
Yeah, it is.
पहले पार्ट का तो आया आंसर,
Yes, sir.
एंड फोर्थ पार्ट का भी वही है, बिकॉज डेल्टा एन जी इज 0.
Yes.
Yes, sir. सबका आंसर एक्चुअली डेल्टा U ही है.
हाँ, then what about the third part or second part, I would say? Right, इतना आ रहा है?
The weights are still doing it.
Yes, sir. Done.
So wait.
So one more.
लास्ट वाले का भी बता दो.
So it's not coming good value. So not coming a good value.
Not coming what?
A good value.
वो ठीक है मतलब आंसर तो आ रहा है ना.
So we need the device that shall not be named.
Right, so delta G will come as delta H naught minus T delta S naught.
So, but what's the T?
T दिया ना 298 Kelvin, like सबके subscript में 298.
Oh,
298.
yeah. Okay.
And once from here you get delta S,
Yes, sir.
and then you can use the absolute values of entropy to determine that unknown entropy.
Yes.
298 Kelvin.
Does it come? Was it does delta S come as total as that minus 10.13?
No, वो ठीक है. I don't exactly know the value it will come out to be, but whatever you will get from these calculations is going to be the correct value. ठीक है?
Yes, sir.
Okay. Now,
Could you just 1 second?
अब थोड़ा सा सब्जेक्टिव पर्सपेक्टिव भी नोटिस करना है यहाँ पर. Now, given data, right, like in the above question, if I give you the adequate data, delta H, delta G, delta S, सब कुछ निकाल सकते हो आप.
Yeah.
Very simple formulas to remember and work with. But sometimes notice karna that you will come across subjective questions. Subjective, I mean to say that there will be no data that will be given to you, and you will be asked to predict sign based on your knowledge of chemistry, based on some soft points to be understood. Delta S का sign कैसा होगा reaction का, delta H का sign कैसा होगा, consequently delta G का sign कैसा होगा, all of that, but without any data, just a balanced equation will be given to you. For example, ठीक है, जैसे ये question है, already मैंने इसका आंसर यहाँ पे लिखा हुआ है, but मैं आपके साथ डिस्कस करना चाहूंगा. हम जैसे ये रिएक्शन ऑब्जर्व कर रहे हैं, PCl5 on heating is giving PCl3 plus Cl2. Now, just by looking at this reaction, okay, without like any data given, I can see 1 mole of gas से 2 moles of gas आ रही है.
हाँ सर.
तो यहाँ पर नोटिस करना that आपके लिए एक important learning क्या है, that entropy, we know solid liquid gas में gases का is much more as compared to solids and liquids. So in a reaction, if there is net formation of gases, okay, more moles of gases are getting formed, like delta Ng is positive, then it is highly likely that the entropy would be increasing or delta S of the reaction would be positive. And in case there is net consumption of gas, right, the delta Ng value is negative, then it is highly likely that the entropy of the reaction would be decreasing, like delta S of the reaction would be negative. Based upon this subjective knowledge, if I am to comment on this reaction, I can see that delta Ng over here is positive, and as a consequence, entropy would be increasing, and the sign of delta S is likely to be positive. What about delta H over here? तो यहाँ पर heating करने पर ये reaction हो रहा है, right? Upon heating, this reaction is happening, so it is highly likely an endothermic reaction.
Yes,
sir.
Yes, sir.
ठीक है. The other way to look at it also is from a bonds perspective. यहाँ पर दो PCl bonds break करने पड़ रहे हैं and right hand side पर एक ClCl bond form हो रहा है. तो overall more energy would be required in breaking bonds.
हाँ सर.
Subjectively कह रहा हूँ, देखो data नहीं है हमारे पास में, but subjectively more bonds are to be broken, less bonds are to be formed. So subjectively we can say it is likely that we need to supply energy, and based on that we can say that delta H is positive.
So, but here we're assuming that pressure is constant, right?
No, even under so when, okay, वैसे तो तुम्हारी बात सही है that in this chapter whenever reactions are going to be discussed, एक unsaid understanding है that we are discussing reactions under constant P, T conditions.
Okay.
That is the most common condition under which reactions are analyzed in our syllabus. अगर कुछ और रहेगा तो mention कर देंगे. But अगर कुछ mention किया हुआ है तो आप यही मान के करोगे कि it is constant P, T. ठीक है? लिखो, and based on this, let me know what do you think about the sign of delta H and delta S for this reaction.
Can you send on chat, please?
Yeah, you can put the answers in chat.
So for delta H, you have to see the bonds broken, right?
Sorry?
So more the bonds broken, more the delta H, right?
Subjectively, yes. Like यहाँ पर data नहीं दिया है ना, तो हम लोग अब एक अंडरस्टैंडिंग ये मान के चल रहे हैं कि ठीक है, बॉन्ड एनर्जीज जनरली डबल ट्रिपल नहीं होती एक दूसरे की, दे आर ऑफ सिमिलर रेंज ओनली.
So if bonds are formed, then delta H is negative.
More bonds are formed.
Okay, so more bonds are formed.
ठीक है, but of course this is not to be taken into too much granularity. मैंने बताया ना यहाँ पे डेटा का अभाव है, तो we are putting in some subjective thoughts.
Yes, so it's majorly for subjective where data is not given.
Ah, yes.
They might just give some exceptional case. In an actual question, they might just give the data. I think that.
हाँ.
So what was the other alternative for delta H? You said something before the bonds.
Like यहाँ पे heating हो रही है ना?
Yeah.
So could you check the chat?
हाँ ठीक है कलश, तुम्हारे आंसर्स ठीक है. रायन, राइट. क्रिश,
I am right.
Thank
you.
But delta S का भी तो दो.
अच्छा, okay.
So got it. So I sent it.
नहीं, absolute value नहीं है, चेंज की बात.
So
ये
I
सर
said,
चेंज का ही भेजा है सर.
yes,
तो
sir.
डेल्टा कैसे डालना नहीं पता था.
Even I said that. So yes,
Then,
sir.
capital D लिख दिया, DS
So
capital
it
DH.
shows voice cracking.
Possibly because I am on hotspot.
The voice is cracking a little bit, but it's all right. So
So यहाँ
नहीं
पर
है my lord.
it's a combustion reaction, so delta H is less than 0. And also the fact that you can see delta Ng is negative over here.
Yes, sir.
कंसेप्शन ऑफ गैस.
है ना? तो एंट्रोपी भी यहाँ पे डिक्रीज हो रही है, डेल्टा एस भी नेगेटिव है. चलो ये वाला क्वेश्चन ट्राई करो.
सर एमटी में पूरा थर्मो आएगा ना मतलब?
हाँ पूरा.
हाँ सर.
so got it. So both favor. Is it A, sir?
Just check it in the module now. So no one else will.
Wait.
Sorry.
So it shouldn't be A, right?
Wait a second.
It should be.
How do we know?
Temperature की value.
It's not A. It's not A.
But
It
both
should not-
H and S are of the same sign. So
Exactly.
if you want it to be spontaneous, delta H should be negative to favor.
Yeah, it's D.
Yeah, but here's the thing. What if the value of delta S is very small?
Doesn't matter, but it will be negative. T delta S will be negative, which favors.
D is.
Delta minus T delta S is positive. It could be A.
Wherever T delta S can be greater than 110.
It's 110 kilojoule, by the way, if you notice. So like there could be any.
पॉजिटिव ना.
You can actually see the bonds.
Not
over
A.
there.
Definitely not A.
All right, so D ऑप्शन आंसर हो जाएगा इसका.
Yes, sir.
Right, delta H positive दिया हुआ है. Right, to favor a reaction, what we want delta G to be negative. ठीक है. अब यहाँ पे सब not दिया हुआ है तो ठीक है. We are left with no option but to check for not values. Although we do know that the condition of spontaneity is on delta G and not delta G naught. But ठीक है. अब दिया है तो उसके साथ वर्क कर रहे हैं. For this to be negative, what do we want? यहाँ पर डेल्टा एच तो दिया हुआ है पॉजिटिव, तो ये तो फेवर नहीं कर रहा है ना, ये तो अपोज कर रहा है. इट इज नॉट मेकिंग डेल्टा जी नॉट नेगेटिव. एंड बाय लुकिंग एट डेल्टा एस, यहाँ पर यू कैन सी डेल्टा एन जी जो है वो पॉजिटिव है, लाइक एंट्रोपी बढ़ रही है तो डेल्टा एस पॉजिटिव है, एंड पॉजिटिव इनटू दिस माइनस साइन विल मेक दिस टर्म नेगेटिव ओनली. So that is the one which is favoring. Right. So based on this, D option becomes your answer.
Or it's
Chicken?
Yes, sir.
Can you scroll up for 1 minute? The H2O question. So can you go to the H2O question? I'll take a screenshot.
पहले इसको लिख लेंगे सब.
So, will
Do
you
we
be
write that thing you've done down?
so so will you be preparing the MT, sir?
Yeah.
Sir has told it.
So why have you written everything twice? So never mind, I got it.
लिखा सबने ये?
So 1 minute.
चलो अगला
Can you
क्वेश्चन.
scroll?
अगला
So
क्वेश्चन.
can you go to the H2O question?
Yeah.
H2 वाले का स्क्रीनशॉट लेना है मेरे को. ये लो. ठीक है?
Yes, sir.
अभी इसका ट्राई करो आंसर.
So can you show it once again? My computer is saying could not open the file.
तो इसमें तुम क्या could not क्या कर रहे हो? डेल्टा एच जो है वो नेगेटिव है बिकॉज कंबस्शन है, और डेल्टा एस क्या होगा वहां पर? नेगेटिव होगा बिकॉज डेल्टा
But
इंजीन.
then one bond is breaking.
Don't
One.
in terms of bonds.
Let's say directly no.
मैंने बताया ना कंबस्शन हो रहा है, तो कंबस्शन में मतलब क्या होगा? हीट रिलीज होगी.
Yeah.
That's it. वहां पे कॉम्प्लिकेशंस आ गई ना बॉन्ड में, सिंगल बॉन्ड डबल बॉन्ड इन्वॉल्व है.
Oh yeah. Okay.
So is the 20th one a multiple choice correct?
नहीं सिंगल चॉइस ही है.
So and delta S was negative, right? Yeah.
So are there multiple correct in this 28th one? So are there multiple correct in this 28th?
No, just one.
Yes, sir. Got it.
Yes, sir.
राइट, तो इसका आंसर है सी
C?
ऑप्शन.
C option.
Yes.
ठीक है, कैसे आप नोटिस करना है यहाँ पर एब्सोल्यूट वैल्यू जो रहती है एंट्रोपी की, दे आर पॉजिटिव ओनली. एब्सोल्यूट वैल्यूज कैन नॉट बी नेगेटिव. नाउ
Yes.
given that understanding, आप यहाँ पे ऑब्जर्व करोगे तो सी और डी ऑप्शन में डी तो गलत हो गया
हाँ सर.
Yes, sir.
और सी सही हो जाएगा. अब ए और बी ऑप्शन को असेस कर लेते हैं. So when you look at A option, it talks about the formation of CO2. This is the reaction for the formation of CO2.
Yes sir.
Now, what do you think यहाँ पे delta Ng है?
Zero.
Delta Ng 0 है यहाँ पर.
Yes.
Yeah, sir.
So it is becoming a tough guess.
हाँ सर.
तो इस tough guess में अब जो एक next level of detail है आप observe कर सकते हो is that O2 was diatomic and CO2 was triatomic. ठीक है, 1 mole O2 गैस से 1 mole CO2 गैस बन रहा है. And you are getting a more atomicity का gas. More atomicity means more possible microstates, and more possible microstates correspond to more entropy. So subjectively speaking, यहाँ पर entropy बढ़ रही होगी, delta S greater than 0 होगा.
Yes.
This is like अगर delta Ng 0 आ रहा है तो जैसे बी ऑप्शन है, बी ऑप्शन में तो डेल्टा एनजी से स्ट्रेट फॉरवर्ड आंसर हो गया. यहाँ पर 1.5 मोल से 1 मोल बन रहा है तो मतलब मोल्स ऑफ गैस कम हो रहे हैं, मतलब एंट्रोपी कम हो रही है, डेल्टा इज नेगेटिव है. सो वी डोंट नीड टू गेट इनटू एनी फर्दर डिटेल. इन द ए ऑप्शन देयर वाज अ स्लाइट बिट ऑफ मोर डिटेल दैट वी वेंट इनटू गिवन द फैक्ट दैट डेल्टा एनजी वाज 0. समझ में आया?
Yes sir.
ठीक है. अच्छा, नेक्स्ट ऑब्जर्व करना. It's more like a note which is saying that if you have knowledge of delta H of reaction, we cannot comment on the delta S of the system, but we can comment on delta S of the surrounding. Why? Because you know the formula for delta surrounding is minus Q system upon T surrounding, and constant pressure conditions में Q system क्या हो जाता है? Minus delta H system. Right? So if the reaction is exothermic, delta H is negative, that means delta S surrounding will be positive. And if the reaction is endothermic, then delta H reaction is greater than 0, and that means delta S surrounding will be negative. समझ में आया?
Yes, sir.
लिखा सबने?
So
So 1
last,
minute.
Yes, sir.
so last line, so one.
So why is there an R under the delta?
Reaction.
Reaction. Okay. Now,
So I think I already know the answer, but why can't we do it?
मतलब
Why can't we comment on the entropy change of the system? Because you need at least delta G for that.
मतलब you will need some more information, and the thing is that delta G comes from delta H and delta S.
Yeah.
है ना? तो या तो आपको अलग से क्वेश्चन में स्पेसिफाई करके दे दें.
Yeah.
ठीक है, जैसे लाइक फॉर एग्जांपल अब कैसा रहेगा? There is one more question that I can put across. एक्चुअली वो केमिकल इक्विलिब्रियम की बुकलेट में है, नेक्स्ट चैप्टर जो है.
So if it's in the next, then you can cover it in the next one. So, okay. That's
ठीक है, अभी let's move on to this next topic. Although it is more from the perspective of physics, ठीक है, chemistry में we don't really bother about these thermodynamic cycles and all, and calculating the efficiencies. But booklet में है, booklet में एक दो questions हैं. Physics में आप पढ़ोगे वैसे, physics में आपको पढ़ाएंगे भी सही, but let me use up the time that we have to study this and be able to answer certain questions that are part of the booklet.
so. So will we be able to answer physics questions using this knowledge which you give us?
Yeah.
Okay. So
Now, notice करना, the topic is Carnot cycle and its efficiency. But before I start with Carnot cycle, I will put forward some general terms to be aware about. One is thermodynamic cycle, other is heat engine, and the third is heat pump. Now, thermodynamic cycle क्या होता है? That I think you are pretty much comfortable and aware with. That a thermodynamic cycle is a process in which you return back to the original state. That is simply what a thermodynamic cycle means. Now, next definition जो है यहाँ पे heat engine, वो notice करना. ठीक है, a heat engine operates on a cyclic process and may perform work on surroundings. तो एक सिंपल सा मॉडल आपके सामने क्या है? a heat engine which is transferring energy from a hot region to a cold region, and in that process converting some of that energy into mechanical work. तो जैसे यहाँ पर आपने नोटिस किया लेफ्ट हैंड साइड पर you have a heat source, it is at a higher temperature, say TH, इसको हम hot reservoir भी बोल रहे हैं. On the right hand side you have a heat sink or a cold reservoir, it is at a temperature TC, a lower temperature. Now you are transferring heat from hot region to cold region, and that is being used by a heat engine, that is our system, which is operating on a cyclic process. Okay? It returns back to its original state, cyclic process पे operate कर रहा है, and because of that operation, because of that cycle, it is able to use some of that heat and convert it into mechanical work. Okay? Some amount of heat is lost or is released into the cold reservoir.
So
the opposite of this, in case the cycle is reversed, where let's say external work, some external force does work on the system, ये जो work का sign है ये opposite हो जाएगा. If let's say मैं आपके घर में जो रेफ्रिजरेटर रखा है उसके बारे में बात करूं, तो let's say some external work, electrical work is done, then it can pump the heat in a direction which is from cold to hot, from a sink to a source, or from a lower temperature to a higher temperature.
So
यहाँ पर एक मिनट रुक जाओ. हीट इंजन जो है वो क्या कर रहा है? That is using a spontaneous phenomena, a phenomena that happens by itself. That heat flows from cold region to, heat flows from hot region to cold region by itself. इसको use करके it is doing work on the surrounding. This is what
So,
a
but
heat engine is.
how is it doing work if heat is just flowing from hot region to cold region?
मैं बताऊंगा, मैं एक एग्जांपल दूंगा आपको. That will be your Carnot cycle.
This mechanism used for refrigerator is same as used in.
जैसे फॉर एग्जांपल यहाँ पर आप नोटिस करोगे, अभी कार्नोट साइकिल में आपको एग्जांपल दिखा दूंगा एक, तो उसमें आप नोटिस करोगे that there will be this heat transfer that will be happening from cold region to hot region, and based on that heat transfer there will be some work that will get done by this cyclic process. Carnot cycle का example मैं आपको दिखाऊंगा. अभी मैं Carnot cycle word नहीं use कर रहा हूँ. I am talking about any general cyclic process.
So
now
So what is the heat?
The opposite is what we are saying is heat pump, where an external work is done and it takes the heat from cold region to hot region. ठीक है, जो कि अपने आप नहीं होता है. Heat never flows from cold region to hot region by itself, but we are pumping it. So we are saying we are designing a heat pump. So in that case, what will happen? External work will be used. Surrounding will do work on the system to take the heat from cold region to hot region.
So the heat released, is the heat not used for you doing work? So you can call that entropy. So like the change in
वो हमने हाँ उस टाइम पे बात किया था जब हम लोगों ने एंट्रोपी का क्लासिकल थर्मोडायनेमिक्स बेस्ड इंटरप्रिटेशन डिस्कस किया था.
And so basically now the heat supplied in the reverse process, the heat supplied will be, and what will be the entropy in the reverse process? So
अभी मैं जितना बताया उतना देखो, फिर मैं कैलकुलेशन बताऊंगा तो आपको थोड़ा और डेप्थ समझ में आएगी.
Yes, sir. So one section.
So, so can you scroll up? I have a question.
कहाँ पर?
We cannot comment on the entropy change.
क्वेश्चन पूछो तुम, बाकियों को कॉपी करना दो.
Okay, so if we have constant pressure conditions, then dq reversible becomes qp becomes delta h. Okay, and then if it's exothermic temperature will probably decrease and endothermic temperature will increase.
Constant P, T conditions पे ऑपरेट कर रहे हैं ना हम.
Oh yeah, okay. So then, because 0 comes in the denominator, so then you don't know what to do. Wait, I don't understand then, because then delta S is equal to delta H upon T.
So,
And T is not changing.
And delta S is not equal to delta H upon T.
In constant pressure conditions and reversible.
Surrounding.
So,
delta S surrounding came as minus delta H system upon T.
So it's minus Q system by T, right?
Minus Q system upon T surrounding, and then Q system was delta H under pressure conditions.
So irreversible.
Correct.
So then integration of dq system reversible becomes q system reversible. If it's under constant pressure conditions, that becomes delta H of the system in a reversible process. So then we know delta H. So then why can't we comment?
अरे यार, तुम भी मतलब लो क्या बोल रहे हो बताओ.
So integration dq, so delta S is equal to integration dq reversible upon T.
No, I am not going that background में, because that background was already discussed, and based upon that discussion I had arrived at the result that delta S surrounding was minus Q system upon T surrounding.
Yeah, this I agree with.
हाँ, तो मैं इसके पीछे नहीं जा रहा हूँ अभी कि ये कहाँ से आया था. We had done and discussed this.
No, no, this is okay. I'm saying, but we can comment on delta S system, no?
How can you comment on delta S system?
Because under reversible conditions and constant pressure conditions, the dq reversible becomes delta H.
नहीं ना राजा, यहाँ पे the reaction is happening. The reaction is not in a state of equilibrium. It is not reversible.
Oh.
तो हम लोग ये डेरिवेशन नहीं यूज कर सकते ना.
Okay.
सर रिवर्सिबल साइकिल में जो कोल्ड ऑब्जेक्ट से हॉट ऑब्जेक्ट पे जो हीट जाएगी, तो फिर हॉट ऑब्जेक्ट की हीट किधर जाती है?
क्या?
So sir, he'll explain it later when he gets into the calculations.
आएंगे अभी कैलकुलेशन पे आएंगे.
And what exactly is the heat system? Because it just feels like it has no point being there. The heat will just flow. Even, yeah.
Where?
Why is there a heat engine over there? What is it doing when the heat is flowing from the hot region to the cold region?
It is using some of that heat supplied
Huh.
and doing a work.
Okay, and it's letting the rest of the heat go ahead.
जैसे हाँ, मतलब जैसे for example, if I talk about your automobile engine,
yeah,
right? अब उसमें the design of it is done in a way that when you burn fuel, it results in heat being supplied, and because of that, then the design of that engine is in a way that pistons move up down.
Yeah.
And work gets done.
Yeah.
And the remaining amount, it gets dissipated into the surroundings.
Yeah, yeah.
Like, imagine if rather than pistons there was just one dabba inside, then it will not be called as a heat engine. Like, you will burn fuel, whatever the heat is there will get released or dissipated into the surroundings.
Yeah. So
That is not an example of a heat engine. A heat engine is something that is designed in a way in which it can exploit that heat transfer and do some work.
yes, sir.
ठीक है, जैसे आपके फोन की बैटरीज होती हैं, तो they are designed in a special manner where a chemical reaction is the energy supplied, and that is used to do electrical work. So there is a lot of ingenuity that goes into design. Now, I'm not teaching you how to design. That is something you will learn if you pursue mechanical engineering in your college.
Yes.
I'm just explaining the overall thermodynamics of it.
Yes.
ठीक है अभी?
Yes, sir.
सर इसका एक अलग से ग्राफ भी होता है ना सर?
आएंगे सब्र करो. इतना लिखा सबने, कार्नॉट साइकिल एंड इट्स एफिशिएंसी.
सर एक सेकंड सर,
ये तीनों टर्म्स लिख लिए. थर्मोडायनेमिक साइकिल, हीट इंजन एंड हीट पंप.
So a refrigerator or a heat pump. So I get the why it's heat pump, but why refrigerator? Like refrigerator isn't just cool. Like
हाँ तो वही तो कर रहा है ना. तुम्हारे घर में जो रेफ्रिजरेटर रखा है, राइट, उसमें जो आप
so I think it's just the one thing. I think it's saying got it. So is it that so the refrigerator is very hot because the heat produced as work is done?
The refrigerator is making something colder.
Yes, sir.
How is it making something colder? It is taking heat from that food, that item that you kept inside, and throwing it outside in your room.
Yes.
Yes, sir.
Right? So it is doing something which is not allowed by nature. That
Yes.
it is transferring heat from a cold region to a hot region.
Yes, sir. Yes, sir.
तो उसके लिए वर्क लगता है ना, बिजली डालनी पड़ती है, इलेक्ट्रिसिटी सप्लाई करनी पड़ती है. ड्रॉ करा है इतना सबने?
Done, sir.
Answer.
Yes.
अच्छा, अब इसके नीचे लिखो that as per first law of thermodynamics, delta U is equal to Q plus W, and because it's a cyclic process, so delta U 0 होगा,
Yes, sir.
and Q will be QH plus QC, and W we are just writing it as W only. जो QH होगा उसका साइन पॉजिटिव होगा, QC का साइन नेगेटिव होगा, and work का साइन नेगेटिव होगा because it is by system on surrounding, right?
Yes.
तो ये लॉ ऑफ कंजर्वेशन ऑफ एनर्जी फॉलो हो रहा है यहाँ पे, फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स. सेकंड लॉ ऑफ थर्मोडायनेमिक्स क्या कह रहा है? सेकंड लॉ ऑफ थर्मोडायनेमिक्स सेज दैट QC will not be zero or the entire heat supplied cannot be converted into work, right? The work done upon heat supplied, which we are saying as efficiency, is going to be less than 1. It is not possible to use a cyclic process to extract heat from a reservoir and completely convert it into work without transferring certain amount of heat from the hot reservoir to the cold reservoir at the same time. Okay, this is another statement of second law of thermodynamics. लिखो इसको.
सर
हम्म
सही सर, वर्क डन का सिर्फ मैग्नीट्यूड क्यों ले रहे हैं सर? नहीं भी लेंगे तो नेगेटिव ही आएगा ना, वो तो मतलब चलेगा ना वो उससे?
हाँ बट मुझे एफिशिएंसी जो निकालनी है उसमें तो मैग्नीट्यूड यूज करूंगा ना,
हाँ सर, यस सर।
आउटपुट बाय इनपुट।
Can we stop here for today?
हम्म
Hello, sir.
हम्म
So can we stop here for today? So we have a test tomorrow. It's very tiring.
Yes, sir, please.
Yes, sir. Please, sir.
Yes, sir, please, sir.
So we need to study also.
Yes, sir.
नाउ अब इसके बाद में नोटिस करना, अ कार्नोट साइकिल के बारे में क्या बताया जा रहा है। अ कार्नोट साइकिल, ठीक है, इसको हम लोग ब्रेक कर करके रीड करेंगे। तो पहले मैं आपको बताऊंगा कि व्हाट इज अ कार्नोट साइकिल। ठीक है, सो आई विल गिव यू व्हाट आर द स्टेप्स, लाइक यू कैन हैव एनी random process as a cyclic process, right? This whatever you feel like, but a Carnot cycle is a particular set of steps. क्या है वो steps मैं आपको पहले बताऊंगा, then I will quickly give you efficiency formula for it. ठीक है, first I will give you the general formula, then I will give you the specific formula for Carnot cycle, that how much heat is converted into work. Once that is there, then फिर I will talk about this maximum वाला part, that how it demonstrates maximum convertibility of heat into work. Like among all the possible general cycles, reversible cycles there are, how operating between two temperatures TH and TC, Carnot cycle gives you the maximum convertibility. ठीक है, तो एक एक करके इसको समझते हैं। सबसे पहले व्हाट इज कार्नोट साइकिल, ठीक है, वो नोटिस करना, एंड लीव स्पेस फॉर द राइट हैंड साइड डायग्राम. First, understand the PV diagram because you are more familiar with the PV diagram. that is something which is comfortable to you. So a Carnot cycle consists of these 4 steps. First is an isothermal expansion at TH. 1 से 2 जा रहे हो आप, isothermal expansion हो गया ये. Then you have an adiabatic expansion. यहाँ पे आप notice करोगे, let me zoom in a bit. This is called as isentropic. Isentropic मतलब delta S is 0 या entropy is constant. So it is your reversible adiabatic process. Okay, so 2 से 3 is your reversible adiabatic expansion. Then 3 से 4 is isothermal compression. And then 4 to 1 is again adiabatic compression. Isentropic matlab adiabatic compression. So this is your Carnot cycle. Okay, leave space for the second diagram. I will come to it in a while. First, draw this diagram.
So isentropic is basically reversible adiabatic, right?
Yes.
So done.
So wait.
Now you can focus on the right hand side diagram also. Right hand side diagram is a T versus S diagram. Now, as you can notice, 1 से 2 में क्या हो रहा है? Temperature constant है. ठीक है, तो ये
Yes.
horizontal line है. But why is the horizontal line moving forward, not backward?
Entropy is increasing.
Why is entropy increasing? Because
why?
expansion of delta S is n CV ln T2 by T1 plus nr ln V2 by V1 ना?
Yes.
Yeah.
तो वॉल्यूम बढ़ रहा है तो ये डेल्टा एस पॉजिटिव आ रहा है ना. ठीक है, तो इसके लिए ये 1 से 2 ऐसा हॉरिजॉन्टल लाइन है. देन 2 से 3 is an adiabatic process. That means entropy is constant, so it's a vertical line. But why is it going down, not going up?
Sir, adiabatic expansion temperature decreases.
Yes, sir.
Correct. Then 3 to 4 and 4 to 1, you can similarly understand and write it down.
So, so could you explain it again, sir and Garrett?
Which part?
So like the whole thing, it's like 1 to 2 and 2 to 3.
तो देखो ना लेफ्ट हैंड साइड में 1 to 2 क्या है? What process is that?
Isothermal, yeah, T is constant, okay.
So it will be
Yeah,
horizontal.
yeah. Entropy is constant, solely dependent on temperature. And then 2 to 3 entropy. Wait, its entropy is increasing from 1 to 2, but temperature is constant, okay. And then entropy is constant and adiabatic. Oh yeah, because Q is equal to 0, right?
Yeah.
So it's 11:45.
So 2 से 3 यहाँ पे क्या हो रहा था?
Temperature decrease.
Temperature decrease.
Adiabatic
Adiabatic compression.
Expansion.
वर्टिकल है.
Sorry, expansion.
हाँ, और एक्सपेंशन हो रहा है तो कूल डाउन होता है. ठीक है, यहाँ तक का समझ में आया?
Yes,
Yes,
sir.
sir.
चलो ठीक है, फिर इसका जो एफिशिएंसी का फॉर्मूला है वो मैं आपको नेक्स्ट क्लास में करा देता हूँ.
सर वो DQ रिवर्सिबल और TDS लिखना है क्या सर वो साइड का?
हाँ 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 बिल्कुल लिखना है. उसको लिख लो, वो आगे काम आएगा. मतलब मेरा जो डेरिवेशन रहेंगे उसमें काम आएंगे.
Bye. So if we are done copying, can we leave?
या
Okay, sir.
Bye.
Thank you, sir. Bye, sir.
Bye, sir.
सर 1 मिनट सर एंड मत करना.
हाँ हाँ.
हो गया सर.
ठीक है, किसी को कोई डाउट पूछना है?
No, sir.
सर एक डाउट था सर. सर
हाँ.
कार्नोट साइकिल रिवर्सिबल साइकिल है तो सर उसको फिर रियल लाइफ में कैसा होगा सर उसका एप्लीकेशंस?
तो डिजाइन तुम पूछ रहे हो ना?
यस सर, मतलब हाँ रिवर्सिबल है तो सर हम उसको मतलब रियल लाइफ में तो नहीं कर सकते सर एग्जैक्टली.
हाँ हाँ. सो यहाँ से जो वैल्यू आएगी ना एफिशिएंसी की, दैट विल बी लाइक अ थ्योरेटिकल लिमिट. प्रैक्टिकल, इवन इफ यू ट्राई टू अचीव.
यस सर, वी कैन नॉट सर.
हाँ ठीक है.
यस सर. सर इसके बाद सिलेबस में और कोई साइकिल है क्या सर ऐसी रिवर्सिबल?
नहीं,
रिवर्सिबल.
कार्नोट ही है जो इम्पोर्टेंट है.
ओके सर.
ठीक है, और भी रहती हैं बट हमारे लिए इतना काफी रहेगा.